Alright, this video we're going to focus on a past exam paper on analytical geometry. Then question 1 says, in the diagram, R has got these coordinates W, T and K. K, we do not know the coordinates. We've been given that letter A and B at the vertices of quadrilateral RWTK. And if we come here, this is point R, point W, T and K. Now, what are the questions? They now ask us to determine the coordinates of M, the midpoint of line RT. So this is point R, this is point T. They want to know the midpoint of these lines. So what is the midpoint formula? Our midpoint formula simply states that in this case, we've been given RT, so it means that the midpoint of line RT, midpoint RT is equal to, then now we say x for point R plus x for point T divided by 2, and then same colon we say y for point R plus y for point T all divided by 2. So now this is the formula. Now we are going to substitute midpoint R2 is equal to, now our x at point R is -5, so we fill out that, okay, we have -5, so we now say -5 plus, and then for point T our x is what? Our x is 6, so we've got 6 here all over 2, same colon. Now we go to point Y for coordinate R is 3 plus the y at point T is 6, so we've got 6 here all over 2. Now here -5 plus 6 is the same as 6 minus 5, which is 1, so we've got 1 over 2 here. And here 6 plus 3 is equals to 9, so we've got 9 over 2. And just like that, we found the coordinates of the midpoint. So we conclude, therefore, midpoint RT is equals to the x coordinate half, the y coordinate 9 over 2. Let's see the next question. The next question says, calculate the gradient of the line WT. This is point W and point T. Now, when you want your gradient is the change of y values over the change of x values, right? All right. So we now say gradient of line. Actually, you don't have to write gradient. The letter M represents gradient. So you say gradient of, we asked for line WT. So M represents gradient WT is equals to, what is the gradient? Now we say YT minus YW all over XT minus XW. Now we come to the coordinates of YT. The y coordinate is 6, so we write 6 here, minus, now we go for coordinate y for point W, which is equal to 0. This is 0, sorry for that, all over xt minus xw. The x on point T is 6, the x on point W is -3. So we have got 6 minus -3. Now we place a bracket here, is equal to, so we are talking about the gradient of WT, which is now equal to 6 minus 0 is equals to 6 all over negative and negative is a positive, so 6 plus 3 is equal to 9. So gradient of WT is equals to 6 over 9. However, there is a common fraction, so if I divide by 3 over 3, I can conclude that therefore the gradient of line WT is equals to 6 divided by 3 is equal to 2, and 9 divided by 3 is equal to 3, and 2 over 3 is the gradient, right? It's a positive gradient. And if you look at the line, Remember, this is an increasing function, line function. So our answer is correct. Now, let's look at the next question. The next question, it now says, prove that RW is perpendicular to WT. So where is RW? This is line RW, and they're saying that we must prove that it is perpendicular to line WT. So what do we know about perpendicular lines? Number one, we know that perpendicular lines, where they meet, they form what? 90 degrees. But in analytical geometry, when we want to prove that we've got perpendicular lines, what do we do? Now we say gradient 1 multiplied by gradient 2, the product, the answer which we get after multiplying should be a -1. If we get a -1, we've proven that they are perpendicular. If the answer is not a -1, then those gradients are not perpendicular. So we already know the gradient of WT because this is the previous question. Now I've got two methods, but I have to look at the mark allocation. The mark allocation here is saying what? 3 marks. The mark allocation is saying 3 marks. Now, I know that the formula says the answer is equals to -1. So I'm not going to waste my time trying to find the gradient of WT. Then I later multiply with, not WT, man. I already found WT. I'm not going to waste my time calculating for the gradient of RW. What am I going to do? This is what I'm going to do. Observe. I'm now going to say that gradient of line RW multiplied by the gradient of line WT is equal to -1. I do not know the gradient of line RW, so I write gradient of RW multiplied by, so this is my variable. Now the gradient of WT is this one, 2/3, which we have proven previously. We now say 2/3 is equal to -1, like that. Now, obviously, we are looking for RW. So what are we going to do? This, by the way, most students, they make a mistake. When you've got a multiplication, this is one term. So what am I going to do? I want to get rid of this 3. So I'm going to multiply by 3 here, and I'm going to multiply by 3 there, because it's an equation. What you do on the left-hand side, you should do on the right-hand side. Now, these two, they cancel out, right? So now, we have got what? 2 gradient RW is equals to -1 times 3. It's a -3. Now, we want the gradient of RW, but we've got a 2 here, and they are multiplying. The opposite of multiplication is what? Division. So I divide by 2. I divide by 2 there. So now I say, therefore, my gradient for line RW is equals to what? -3/2. And if I come here and I say -3/2 multiplied by, what did I have for gradient WT? 2/3. Multiplied by 2/3 here. Observe. These 2 cancels out that 2. These 3 cancels out these 3. So here I've got 1, there I've got 1, but this is -1. And -1 multiplied by +1, it gives me a -1. So then I conclude that, therefore, line RW, this symbol, it means perpendicular. So line RW is perpendicular to line WT. And just like that, we are done. Now, we come to the last question, right? So what am I going to do? I'm going to erase so that I can have space to work on. But this is the last question, and the last question contributes 4 marks. And it's a very simple question. These are 4 marks which were donated to you by the examiner for those who wrote this at that time. Now they are saying, if RWTK is a parallelogram, determine the values of A and B. And remember, the values of A and B is this point, what? AB. Now, what do I have? This shape which I have here, this parallelogram, is what we call a rectangle. What do we know about a rectangle? We know that since we have proven that this is perpendicular, remember we said that it's 90 degrees. We know that these angles here of a parallelogram code rectangle are equal to 90 degrees. What else do we know? We know that in between this line RT, this diagonal line, and that diagonal line, what? KW, here is a midpoint. So a KWR, let's call it point S here, but we are not going to write about it as S. Now, if you remember, in the beginning of the question, we were asked to find the midpoint of RT from point R to point T, and we're saying that they've got a common midpoint. The coordinates which we found for RT were what? Oh, and I erased the answer. So let me just quickly say -5 plus 6 divided by 2, that is 1/2. So we said that the x coordinate was 1/2, and y was what? 3 plus 6 divided by 2, 9/2. 9/2. So these coordinates, they are common for line WK as well as line RT. So what am I going to do? I'm now going to use the midpoint formula. Remember, my midpoint formula says what? I'm now dealing with KW. Let's write it down so that it makes sense. So I say midpoint KW is equal to what? XK plus XW divided by 2, and we have YK plus YW all over 2, like that. Now we now substitute with numerical values, right? The midpoint of KW, it is the same as the midpoint of what? RT, 1/2 and 9/2. So the x coordinate is 1/2, the y coordinate is 9/2. Observe. And then our point at point K, our x coordinate, we know that it is what? A. So here we say A plus our point X at point W is -3. So I say -3 here, or divided by 2. And then our y value at point K is B, plus our y value at point W is 0. We say divided by 2. But when it's like this, we can't go ahead and calculate it. So what are we going to do? We're going to start by calculating for point A, and point A is X. So now we take this midpoint X, we say 1/2 is equal to A, and plus or minus gives us a negative. So we've got a -3 here over 2, right? Then from there we want to get rid of these 2. So we multiply by 2 here, we multiply by 2 there, okay? Then we say this cancels that. So we've gotten rid of this denominator. We need to get rid of this denominator as well. So we multiply by 2 this side, and we multiply by 2 that side. These 2 cancels out that 2. Now we multiply. 1 multiplied by 2 is equals to 2. So we've got 2 here is equal to. Here we cancelled. So now this 2 multiplies with A. Then we've got 2A. -3 times this, it's a -6. Now we're going to transpose this -6. So now it's 2 plus 6 is equals to 2A. And 2 plus 6 is equal to 8. So we now divide by 2 on both sides. Therefore, we conclude that our A is equal to 4. So we found the A coordinate, and then we now go to point B. And the midpoint for the y value was what? 9/2. So we now say we have 9/2 here, which is equal to what? Remember, B plus 0/2. So we now say B plus 0/2 there. We need to get rid of these 2. We follow the same procedure. We multiply by 2. We multiply by 2 there. We now need to, so this 2 cancels out that 2. Then we need to get rid of these 2, so we multiply by 2 here, and we go and we multiply by 2 there. These 2 cancels out that 2. Now we say 9 multiplied by 2, which gives us what? 18. 18 is equals to 2 multiplied by b, which is equals to 2b. 2 multiplied by 0 is equals to 0. So now we divide by 2. Therefore, we conclude that b is equals to 2 into 2 is 1, and 18 divided by 2 is equal to 9. So we found that b is equal to 9. So now we conclude that the coordinates at point K, our a is 4, which is the x value, and our y value, which is b, is 9. And just like that, we found our coordinates for point K, and these are 4 free marks. Alright, if you found this video to be helpful, what do you need to do? Please consider subscribing, like, comment, and share. Thank you very much.